Welcome to this video. I'm going to show you step by step how to use the pivot module for IRRICAD standalone, which is available in version 21 and up. Previously, to design a pivot system in IRRICAD, you would use mainline demand points to manually specify the assumed flow and pressure at the pivot. You then draw arcs manually to indicate the wheel tracks and spans. With the pivot module in IRRICAD, you can now automatically draw full or part circle center pivots, complete with wheel tracks and pivot arm via the click of a button. Specify the required spans, outlet pressure and application requirements in an easy-to-use dialog. Analyze the pivot based on the pivot specifications and the current position of the pivot arm, including the elevation changes under the pivot arm. Analyze the pivot arm and can report on the required pressure and theoretical output flow. Generate maps that display pivot-specific information about the pivot area and pivot arm, such as gradient, angle, twist of the pivot arm, and outlet ground clearance along the spans. Create an exclusive water source and pump for the pivot if required. As you can see, the pivot module in IRRICAD offers a set of comprehensive tools that will not only save you lots of time, but will also let you design center pivots with confidence. This is just the beginning of what the module can do, and we'll explore more in the rest of the training video. Before we begin, first-time pivot module users, make sure you have the pivot module enabled. If you have the IRRICAD Pro V21 version and you do not see the pivot menu, go to Help, click on Check for updates and follow the steps. If the pivot menu is grayed out, then the free trial period has passed and the pivot module option needs to be purchased. How to use the pivot tool is outlined in detail in Help, Release Notes, Pivot Module. This manual gives you a list of all the features that are available in the pivot module. In this training, we'll design a full circle center pivot with the goal of covering the maximum possible area of this land section. IRRICAD will calculate the required flow rate based on the field area, application needs and irrigation time. We'll learn how field elevation affects the pressure and how to account for it in the design. We'll generate pressure maps to identify areas with potential pressure issues. Then we'll design the mainline pipe that delivers water to the pivot. Finally, we'll expose various reports available to analyze the pivot design. We have an existing design with the boundary already drawn. To make it easier to follow along, we just turn off the image and elevations layer. To quite easily maximize the area of the land for a full circle center pivot, we can use the handy circle drawing tool called Seed. The tool can be found in Draw, Circle, Seed, and click in the boundary to create the largest possible circle. Press Escape on your keyboard to tell IRRICAD you're finished with placing the circle. Select the circle and click on Information. And here we can see what the radius is and what the area coverage is of the circle. Alright, that's good to know. The last thing I want to do before placing the center pivot is I'm going to set the database symbol size. I can do that by going to Settings, Miscellaneous. We're going to fill in here 5 meters and click OK. Now we're going to place the center pivot. Select the circle by clicking on it. Go to Pivot in the menu bar and click on Place Pivot. Click on Yes on the question if you want to create the pivot from the selected entity. And now we can fill in the pivot parameters. Please note that if you're unsure about what certain terms mean, or you need a refresher, you can find the explanations in the release notes that I showed you in the beginning of the video. Alright, back to the training. A lot of settings and colors are already predetermined. I will not change too much, but you will have the freedom to change it in a way that suits your situation. I'm going to set the height to 3.6 meters. The height refers to the height of the pivot point, and I'm going to set the outlet diameter to 15 meters. The outlet diameter refers to the wetted diameter of the sprinkler that will be used. And I'll go to the next step. Here we will fill in the crop water requirement of 7 millimeters per day. We'll leave the pivot operational hours on 22 hours per day. We leave the efficiency on 95% and set the pressure regulator at 15 meters. And lastly, we'll pick the 6-inch Nelson solenoid valve. And we'll go to the next tab. Here we're adding an extra length, as this example has an end gun which is always on. In this way, the theoretical flow for the end gun will be added, calculated from the additional area and application rate. So by extra length, we'll type in 13.2 meters. The tower height will change to 4.2 meters. The sprinkler spacing will change to 1.52 meters. And the outlet height from the ground will change to 1.8 meters. And we'll set the overhang to the same parameters as the other spans. And we'll click OK. The pivot will appear with a pivot arm in the 45-degree direction, and the dashed circles are the wheel track locations. For this exercise, we'll place the water source in the lower left corner of the field, as this pivot does not have its own exclusive water source. We can do this by going to water supply. We'll place the water supply in the lower left corner. The following pop-up will appear, and we'll change the symbol size to 30. We'll make sure calculate pressure is selected, and we click OK. Next, we'll connect the water source to the pivot point. We can do this by going to mainline. We'll leave it at computer is selected. We click OK. We'll click on the water source. And then we'll click on the pivot point and press escape. I would like to double check if the water source is connected to the pivot point. I can do this by going to design and check outlet connectivity. And we can see everything is connected. Now we will quickly run through a couple of steps to be able to analyze the report. We do this by going to design, zone design, and analyze. Okay. Design, assign all zones to one system flow. Okay. Design again, mainline design, and LP design. The mainline changed color, so that means IRRICAD assigned a pipe size to it, and we'll keep it with that for now. The first report I would like to assess is the pivot span summary, and you can find that report in Reports, Zone Design Reports, Pivot Span Summary. This report gives us a lot of valuable information, but as the design is performed on the current pivot arm position, it will be helpful to position the arm to the worst position. That is one where the elevation change is the most. One of the ways to find the worst position for the pivot arm is by going to Reports, Show Zone Pressure Limits, and All Items. And if we zoom in, as we can see in the top left hand corner, we can find the point where the pressure will be the lowest, approximately 1.8 meters. This means that the pivot arm is currently not in the position that represents the worst case scenario for the field. I'm curious what's happening with the elevations. Let's turn the elevations layer back on and investigate the elevation around the lower pressure mark. I go to Tools, Highlight Elevations. I'll leave this as it is, but I will create a legend. As you can see, this is handy to quickly figure out the elevation changes in the land, with blue being the lower areas of the land and red being the higher areas of the land. Next, we zoom into the pivot point and double click on the pivot symbol. We change the pivot arm to 95 and click OK. And we'll just zoom out again. And now the pivot arm is closer positioned to the lower pressure mark. When you change the position of the pivot arm, it's important to rerun the design steps again. You can do that by going to Design, Zone Design, Analyze, OK, Design, Mainline Design, Analyze, and that looks good. Now we want to update the minimum and maximum pressures We can do that by going again to reports, pressure limits, all items. And now if we zoom in, we can see there's about 1 bar of extra pressure compared to previously. So the lowest pressure point is much more acceptable than it was before. To figure out what the required pressure going into the mainline needs to be, we go to Reports, Mainline Design Reports, and click on System Duty Report. There we find that the pressure needs to be at least 5.8 bar. If we want to assess the elevation changes along the length of the pivot boom, we can select the gray line. We can go to Reports and click on Hydraulic Grade Line. This graph shows the total length of the pivot boom. And in the legend we can see that the black line is the actual pressure, the red line is the minimum allowable pressure, and the blue line the maximum allowable pressure. And the red hatched area is the contour of the land. If we click on a point in the graph, it will show up in the design as well, indicating the location. To assess the elevation changes along the wheel track, we select a circular dashed line. We go to Reports, click on Elevation Profile. As you can see, there's a fair amount of height changes along the length of this particular wheel track. Alright, that's good to know. Let's now generate a visual of all the different pressures across the total area. I'll first turn the elevation layer off, because we're going to generate lots more colors. I'll select the pivot point, go to Reports, click on Show Zone Pressure Map and selected items. We're gonna give it some custom limits. At minimum pressure we'll type in 15 meters and maximum pressure we'll type in 40 meters and we will create a legend. Okay, and this will give us a clear visual of where the higher pressures are and where the lower pressures are. Let's clear the symbols and check the elevations map. We'll first select the pivot point again, go to Reports, Show Zone Elevation Map and click on Show Map. And let's create a legend. Okay. And this will give you a clear visual that this area is a fair bit higher than this area. With the pivot module, it is possible to generate multiple different types of graphical maps to determine the gradient/elevation change along the wheel track, angle or flex between spans, longitudinal twist on each span, ground clearance under each span. Let's try every type of map. I will clear the symbol and we'll center the pivot in the middle of the screen. We will start with the gradient map. Select the pivot point. We'll go to Pivot, Show Pivot Maps. We'll choose Show Gradient Map. We will leave the limit at 10% and the step at 3 meters. We create a legend and we click OK. And here through the colors we can see where the gradient is quite a bit and where not so much. Alright, that's good to know. The next map is the angle map. We'll first clear the symbol, clear gradient symbols, then we'll select the pivot point, go back to Pivot, Show Pivot Maps and Show Angle Map. I'll change the limit to 7 degrees and we'll leave this step at 6 and we will create a legend. Okay. And you will see at the dark spots the angle is more than 7 degrees. Alright, that's good to know. The next map is the twist map. We'll first clear the symbols, clear angle symbols. We'll select the pivot point, go back to Pivot, Show Pivot Maps and Show Twist Map. We'll leave the limit at 10 degrees and we'll leave the step at 6 degrees as well, but we will create a legend. And you will see at a few spots the twist is more than 10 degrees. Alright. The last map is the ground clearance map. Let's clear the previous twist symbol. clear twist symbols, we'll select the pivot point, go back to pivot, show pivot maps, and we'll click on show ground clearance map. By limit, we'll fill in 2.5 meters. Step we cannot change, and we will create a legend. And you'll see at the dark spots the ground clearance is more than 2.5 meters. Alright. Those were the core features of the pivot module. Lastly, I'd like to make you aware of two more easily overlooked features. They are regarding the water supply. In the video we placed the water supply in the lower left corner of the pivot and connected the pivot to the water supply with a main line. It can happen that a well is located near the center of the pivot and there is no main line. In that case we can select the box in the tab Requirements to give the pivot its own water supply. I will show you where you can find it, but I'll first clear the symbol. We double click on the pivot point. We go to the tab Requirements, and as you can see, you cannot click the water supply option because it currently has the main line attached. We will delete the main line and the water supply. We double click again on the pivot point. We go to Requirements, and this time we can select the box of the water supply. Now that the water supply has been enabled, if a known mains pump is to be included in the design analysis, it can be specified here, and the water supply details set to the well water level here. Otherwise, leave the water supply to report the system requirements so you can size a pump later. Alright, I hope you find this video helpful. Other functionalities and options can be read about in the release notes in the pivot section. Let us know if you have any questions, and thanks for watching.